Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore the application of Docker in data engineering workflows. Okay, so before going ahead with this particular software platform usage in data engineering or data pipeline use cases, we should have some fundamental idea around it. So if you know what is Docker, well and good, but if you don't know, I will recommend to go through this particular video of Christian, which explains the fundamental concept of Docker in a very well manner for beginners. Okay. In short, we can say that Docker is nothing but an open source software platform that enables the developers to create, deploy and manage applications in a wide variety of compute environment. Maybe that is Windows machine, maybe that is Mac OS machine, maybe that is Linux machine. In any kind of compute environment, you can create application, you can manage it and deploy it using this particular software platform. Okay, so there are some basic terminologies with which we should be very clearly aware of. So let me just introduce those terminologies with you. Okay, so first is Docker file. So what is Docker file? It is nothing but a text file kind of thing where we will be writing what all modules or packages we need to install in our environment before running our application. So think like this way. Suppose you are building a Python package. What we do? First we write some certain Python code, right? That Python code we package it up. So similarly here in the beginning we write a Docker file. Like think like this. Okay. Then what we do? We build this particular Docker file, and after building what we get, that is called Docker image. Like for example, when we are ready with all your Python codes, we package it up and that time we call it as Python package, right? Similarly, in this case, once our Docker file is ready, which is nothing but kind of a text file, once our build process is complete, we get a Docker image. It is nothing but a lightweight standalone executable package that contains everything to run our application. Think like this way. Okay. Now, once the Docker image is built, what we do? We basically run this particular Docker image. And once we run this, it basically create a container. And container is something kind of an isolated environment you can think of where our actual application is run. So these are the very important terminologies with which you should be very clearly aware of. One is Docker file that we need to create, where all the installations or steps, whatever we have to perform to start our application, that we'll be putting. And then we will build this particular Docker file, and from that we will be getting Docker image, which is nothing but just like a Python package. So what we do when we build a Python package, we just do a pip install and we can start using it, right? So similarly, once all your Docker files installations are completed, it basically create a Docker image, which is nothing but a lightweight standalone executable package, just like Python package. And like we do pip install Python package and then we start using it. Similarly, we have to run the Docker image to start the container. That is nothing but an isolated environment where our application will be running. So these are the simple workflow to build any Docker container. And obviously, just like you have built a Python package, what we generally do, for example, we are having some sort of repository where we push our package so that other people can pull it and start using it, right? So similarly, this way, in case of Docker, we are having something called Docker repo, just like GitHub repo, okay? Where what we can do, once our Docker image is created, we can push this particular image in Docker repo. So here I can write push, and once maybe some developer want to run certain application, and if they know that this is the image which we can easily download and run it to create our container and start the application, so that time what they can do, that time from this Docker repository, they can pull this image and just run that particular image to start the container within which our application will be automatically started. Okay, so Docker repository is something which we should be having some sort of idea. For example, we are having Docker Hub, where many public Docker images we will be getting, but this is kind of mostly used for personal projects where you can make your Docker image public. But suppose you are working for some industry, then whatever Docker image we build, that we cannot simply put in public space. So that time we should be having some sort of private repo. For example, in a very popular private repo is ECR, Elastic Container Registry. So this is basically provided by AWS, a cloud service, where we can push our Docker repository and pull it whenever needed. So this repository we can make it private, and that way it will be more secure. So many industry whoever are working with AWS cloud, they prefer to push their Docker images in this elastic container registry instead of Docker Hub, right? So this is the fundamental concept around Docker. So in our next section, we will try to implement the Docker project, whatever Chris has explained in his video. That same thing we will try to implement from scratch in Amazon EC2 machine, right? Stay tuned. So now we reach to the second section of our discussion, where we will try to install Docker in Amazon EC2 machine, and we'll try to run our application within a Docker container, and the container will be building by following this step. First we'll be having a Docker file, we'll try to build that and then create the Docker image out of it, and then when we'll try to run the Docker image, the container will be created, which is nothing but an isolated execution environment where our application will be running, right? So in this particular section, to explain the Hello World Docker, I'm going to use the same Hello World use case, whatever is explained by Chris sir, and this is the repository for it. So here if you see, Hello World is this particular directory within which all the required files are available to run our primary application. So the first code what we are going to explore is app.py. Here if you see, it is a very simple Flask application where we are returning Hello World, and the Flask app is running in 0.0.0.0, that is in our local host, and the port is 5000. And we have created this particular Flask app by importing the Flask and all other necessary module like NumPy and Pandas also imported, but although we are not using it, this is just used to show you that we can basically install different Python modules also in our Docker container. That's it. Okay. So if you want to explore a little bit more in depth on Flask and how to build API out of it, I will suggest to go through the video links available in the description box, because I have already explained in detail how to implement or create an API using Flask, right? I'm not going to that Flask part, but rather we'll focus on how to create this particular API and run it from Docker container. So here, let's go back to our parent folder, that is Hello World. Here you can see requirements.txt is available, where all the required Python modules is mentioned like Flask, Pandas and NumPy. That is also understandable. Now let's go to the Docker file. This is our main point of interest, using which we are going to build our Docker image and from which we are going to build our Docker container. Okay. So here 5 lines are written. I have copied that same 5 lines in this notepad, and I will explain each line's significance. Okay. So the first is from. So what is from doing? The from instruction in any Docker file specifies the base image that the container will be built on top of. This instruction typically the first line of a Docker file, and it is used to set the base image for the container. And the format of the instruction is from, and then we can provide the base image like here we are mentioned. So what it is, if you try to relate with our theoretical discussion, that is, first we are creating a Docker file and then we are building our Docker image, which is nothing but a standalone lightweight executable package. It is nothing but a Python package, you can think. So when you create a Python package, it is not like everything you try to build from scratch, right? Maybe in that Python package, you are using Pandas or NumPy. So Pandas and NumPy, you can consider the base Python package, on top of which you are adding some more piece of code to create a new Python package, right? Similarly, here in this case, when we are creating a Docker image, it is not like we are going completely to the scratch level and we are building from scratch. It is like we can use one existing base image. On top of that, we can put some our required code, and then we can build a new image out of it. So that same process is followed here. First, we are taking a very base image, Python 3.7, which is basically nothing but an executable package within which Python is already installed. Okay, right? So I hope the importance of from part is clear to you. Now this copy part. What this copy part is doing? Use the copy instruction to copy the local files from the host machine to the current working directory within our Docker. Okay, and the command is copy, and then some file we can mention which we need to copy to the Docker environment, and then within that particular Docker environment in which directory we need to copy that particular file, that we need to mention. So in simple words, we are having our host machine and we are having our Docker which is running in host machine, but it is nothing but an isolated environment. So if we need to move some code from host machine to the Docker, that means in that isolated environment, that time we can use copy. So using this particular command, what we are trying to say, that copy everything, whatever is available in our current working directory in the host machine to the app folder which is available in our Docker execution environment. Okay. Now the next command, working directory is /app. So what it is? In a Docker file, the work dir instruction sets the working directory for any command that follows it in the Docker file. That means after putting this particular command, whatever command will be putting after work dir in this particular Docker file, that will understand that /app is basically our working directory. So suppose you need to refer some particular file path which is available in that Docker environment, you can mention the path after /app. It is available within app folder. Okay. So Docker will by default understand that /app is nothing but our working directory within Docker execution environment. And the command is work dir, and then you can mention the folder location within Docker, which will be treated as our working directory in the code. Okay. Now the next is run command. What this run command is doing? Use the run instruction to execute commands that will run during the image build process. So here, when we are going to build our own Docker image, that time, for example, in this particular use case, when we are trying to run our Flask app, before that, we need to make sure that in that execution environment, all these pip installation are done beforehand, right? How we can do? There is pip install -r requirements.txt. This command we need to execute. Now to execute this particular command, we can use the run feature of our Docker file. Okay. I hope that particular concept also is pretty much clear to you. Now the last is command. So what this CMD is doing? In a Docker file, the CMD instruction sets the command that will be executed when a container is running from the image. Okay. So what it is trying to say that first we are having a Docker file, from there we are creating a Docker image, basically building that image out of the Docker file, and then once the image is built, we are basically running that particular image, and that is basically creating a container. Now within our container, the application will be running. Now how to run the application when our container is spinned up? That we need to mention in the Docker file. So that is nothing but this particular command. That is to run our Flask app once our container is up. To run that, we can execute Python app.py. That is how we normally execute our Flask app, or how we normally run our Flask app. That same command we have mentioned there, right? So I hope these fundamental commands related to Docker is clear to you. Suppose you need to set up some environment variable, then you can set up like this way: env, then what is the variable name, like node env, and that value part is production. So if you are putting this particular command in your Docker file, so when your container will be spinned up, and if the application requires somewhere to access the node env environmental variable, it will easily access that, and the value whatever it will be getting, that will be nothing but production. Okay. Like that way we can configure the environmental variable as. So this is our pretty much hello world Docker file. Now without any further delay, we will try to install Docker in the Amazon EC2 machine by following the installation steps. So here we are having our steps mentioned. So what I'll do, I'll go to my Amazon management console, and here I will try to launch one EC2 machine. Okay. So launch instance, Docker demo YT1, and Linux machine is fine. This particular AMI I can choose. T2 micro is fine. The key pair I can choose this existing key pair. I'll allow all traffic as of now, and without changing any other properties, I'll launch the instance. So here you can see the instance is currently in pending state. Till then what we'll do, because we are creating a Flask app, so it should be accessible from internet. So for that, as of now, in the security section, I'll go, and in the security group, I will edit the inbound rule, and I'll make sure that from all traffic, it is accessible anywhere IPv4 location, and I'll save this rule. Now if I go back to our EC2 dashboard, here you can see our instance is running. Now I'll copy the public IP, and I will try to enter in it using putty. I'll choose my PPK file, open this one, and click on open. This particular pop-up will come. Just click on yes. Now login as. So we can log in as EC2 user. Okay. So here, to avoid timeout, I'll change the setting also. Here I can put 10 seconds, and I'll apply this one. Okay, cool. Now here we need to do all this execution to install Docker in it. First we are updating if anything is not updated. Then here we are installing Docker. So this is done. Now here what we'll do, we'll start our Docker service. So it is also done. Now we need to execute this particular code as well. So once that is done, we can close this particular terminal and open again in Putty. Kind of we are restarting the terminal. We have pasted the API and I'll choose the authentication file as well. Login as EC2 user. I'll change this particular setting again to 10 and I'll apply this. Right? Now we need to check whether Docker is installed or not. To check that, we can execute docker info command, and if it is returning this kind of result, that means you can understand in your EC2 machine the Docker is installed successfully. Now what we'll do, we will first do git pull. That research repository will try to pull it in our EC2 machine. So for that we need git. So we are installing git. Once that is done, we'll check whether git is installed or not using git version. So if we execute this particular code here, it is returning the version number, that is fine. Now we are going to create hello docker working directory. That is also done. I'll clear this. Now here what we are doing, we are cloning the repository from GitHub to this particular hello world directory. Git clone command we have executed and it is installed. If I do ls currently, here you will see hello docker. So let's go inside this cd hello docker. Now if I do ls, here you can see whatever files was available in our GitHub repository, those are now available here, right? Now here we can go inside hello world, this particular folder. Basically if you observe here, our main folder is hello world within which all the files are available. So we'll do that, and when this time we are doing cd, that time we are keeping hello world, this particular folder location within a single quotation. The reason being, in between hello and world there is a space. To avoid the issue, we are putting that inside single quotes. Okay. Now our Docker file is already available. Now if you recall the flow, what we need to do, we need to build the image out of it. So to do that, this is the command. That is docker build -t welcome app dot. So what it is saying, that docker build command is basically used to create a new Docker image from the Docker file. That is step 1. I hope it is clear to you. Now -t welcome app is basically tagging welcome app this name to that Docker image. I hope that is also you got it. And this dot is nothing but saying create the Docker image based on the files available in current working directory. Okay, using dot we basically mention the current directory. So that's what we are doing here. Because if you see currently, if I do ls, here all the files are available, and here our Docker file is also available from which our Docker image will be built. So that's what we are mentioning here. So let's try to build that image out of it. Here you can see it is downloading some required components, and once our Docker image will be built, we will able to see in the console that whatever steps we have mentioned in the Docker file, all steps in the backend it has executed and created the image out of it. So let's wait for a few seconds. So here it is done. It might throw some warning, you can ignore that. Now if you check the logs, here you will see all the step 1, step 2, step 3 it has executed. Like step 1, we needed a base image Python 3.7. That means in that particular package already Python 3.7 is available. We no need to install Python separately. Then what we are doing, we are copying all our files from our current host, that is from our EC2 machine, from this working directory to the /app directory within our Docker environment. Okay, because we will run our application from Docker environment, not from our current host, right? So all the files, whatever are available in our current working directory, that means these files, if you observe, these ones has to be copied from current directory to the Docker. So that copy command is doing. Now we are mentioning in that Docker environment, the working directory should be /app. Once that we are doing, we are installing the requirements.txt file. That means whatever is mentioned in requirements.txt like Flask, Pandas, NumPy, all things it has installed. Once step 4 is done, it has created the Docker image, and that CMD part it will execute once we will create the container out of it. So now we need to see whether Docker image is really built or not. So how we can see that? So for example, what are the files available in our current working directory? How to check that? We can basically execute ls command. So let me show you that. So I'll first clear this, and if I execute ls, here we can see all the files available in our current environment. Similarly, to see what are the images available, what we can do, we can take help of ls command only. But before that, we need to write docker image ls. That's okay. So docker image ls command is basically helping us in listing down all the images available in our current execution environment. So two images available. One is Python base image, on top of which basically we created our image, right? So that image it has listed, and apart from that, we created a new image from our Docker file and we tagged that particular image name as welcome-app. So that is also it is showing, right? Base image is having the size 994 MB. On top of that, we have done different pip installation. So the image what is built out of our Docker file that is having higher volume, that is 1.15. I hope all these things are easily understandable and pretty much intuitive, right? So to view all the images, as I have already told you, docker image ls, this command we can use. Now our image is built. What is our next step? We can run this particular image to create the container out of it, where our application will be running. Now to do that, we can take help of this particular command, docker run -p 5000:5000 welcome. So what it is doing, let us try to understand. So docker run command basically uses the created docker image and it run that image and create a container out of it where our application will be running. Okay. So docker run, and then here we are mentioning our image name, which is welcome app. What this -p it is doing? So if you see our Flask code, if I go to the app.py, the Flask code is running in 5000 port in our local machine 0.0.0.0. Now when this will run in container, within the container in port 5000 it will be running. But suppose we need to access it from EC2 host machine. So how to do that? So to do that, we do port mapping. That is, that particular container port 5000 should be mapped to some host port. Okay. That is basically to some port in our EC2 machine. So that port mapping we are doing here. Okay. So we are mentioning that from that container where our application is running in a separate isolated execution environment, from that particular system, that 5000 port, we are mapping to our host port 5000 so that we can access that Flask API from our host port 5000 only. Okay. So that is this particular command, docker run -p 5000:5000 welcome. So now what we can do? We can basically run this particular command. Okay. So once we are running, our Flask API is started. All we can do, we can copy this particular public IP of EC2 and we can put 5000 in it to run it. Okay. And here you can see hello world is coming. If you go and see our putty, here you can clearly see one GET request is made out of it. So if I refresh, then also you will see that another request will be created, and here it has thrown one particular another GET request. Somewhere might be it will show. So I can copy this particular endpoint and I can try in incognito window also. So here you can see it is throwing hello world, right? So that means now our Flask API, whatever we have created, and that is running within Docker environment, not running in our host machine, right? How it is running in that particular Docker environment? It is running because here we have mentioned that if you see our Docker file, here we have mentioned command, what it should run within our container, and that is Python app.py, using which we are running our Flask application within the Docker container. So I hope you pretty much understood this particular process, right? Now let's go to our steps. So here our Docker container is running. To view all the running containers, you can execute docker container ls. Okay. So that I can do by basically duplicating this particular session only in a separate putty. I can log in as EC2 user, and then currently I can do ls. So we can do hello docker, and then we can do ls. So here we can do hello world, and here I can paste docker container ls, and here you can see our container ID, it is returning the image ID from where the container is built. That image is welcome app. The command what the container has ran to start our application is Python app.py. So this is basically the command which we generally use to run our Flask app from local also. The same command our Docker is using within a separate isolated environment, and that is nothing but Docker container, right? When it is created about a minute ago, status it is throwing, and the port. So in container it is running in 0.0.0.0:5000. Now from container it is not accessible outside anywhere. To access that from outside world, we are doing a port mapping. So from this container port, we are mapping that same to our host port. So that way, using EC2 public IP and the port number, we are able to access that. So here you can see hello world, it is throwing, right? So here, I hope the fundamental concept of creating Docker file, then Docker image and Docker container is clear to you. Now, if you want to check all the running container apart from Docker container ls, you can execute Docker ps also. What ps stands for? It is nothing but indicating process status. Okay. So here I can copy this and here I can paste this Docker ps. Here also it is returning the same thing. Suppose you want to see all the containers, whatever is currently running and whatever is stopped. So to check that, you can execute this command docker ps-a. It will list all the containers, whether it is running currently or it is stopped. Okay. Currently we are having only one container running. We don't have any stopped container. So it is listing down here. Okay, cool. So maybe here I can stop this particular Flask app and I will clear everything. And then here I will run our image again in some other port mapping, because already in our current host 5000 port is busy for one particular container. So maybe I will change this port number and I will start running it. And here you can see currently we have mapped to 5002 port. So from 5002 also it will be accessible. If we execute, here you can see hello world is coming. And not only that, here if I execute docker ps-a, you will able to see currently two containers is created. The first container we exited, right? So exited 31 seconds ago. So if I just execute here, now if we try to access 5000, here you will see it is basically rotating and it will show the site cannot be reached, because we came out of that particular container forcefully using Ctrl C, right? So currently our new container is running in 5002 port. And to check the containers, so we are having one container which is stopped, one which is running. So to check that, I am executing docker ps-a command, right? And it has listed the two containers, the comments whatever it has run. For the first container, it is showing the status exited, and for the newly launched container, it is showing that it is up and running properly. So I hope the fundamental concepts is clear to you till now. Now to stop the container, what we can do? To stop the container, we can execute docker stop and then provide the container ID. So here if you see, we are having currently, if I do docker container ls, so here you can see we are having only one container running. Suppose I want to stop the container, we can execute docker stop and we can just provide the container ID. That is basically this one. Okay, and we can hit an enter. As soon as we are hitting an enter, it is in the backend stopping the container. That means this process is stopped. That way our application will also be stopped. Okay, so I hope you understood this. So here let's see. So it has stopped it. Now let's try to refresh and try to make a request to this particular endpoint, and here you will see that it is showing nothing. That means our Docker application is stopped. And here in this console where our Flask API was running, here also you can see it is now in the terminal section. That means it came like Ctrl C. Okay, cool. So I hope the Docker container stop process is clear to you. Now another very important point is, although we stop the container, but the images will still be there. So if you observe this diagram, we have just stopped the container and we have stopped the application, but images we have done nothing, right? Images is there. If we need sometime in future, we can again run the image to create a new container out of it. So that's what is mentioned here. Very important point. Although we can stop the container, but still images are there, and we can execute docker images command to check whether it is there or not. So I will execute docker image. Here you can see the two images whatever we were getting earlier. One is Python base image, one is welcome app image, what we have built out of Python base image, right? Both images are still available. Cool. I hope you understood this. Now we have stopped the container. Suppose you want to delete the container. To do that, we can execute this command docker container rm, then the container ID. Okay. It is to delete the container. So here I can execute this one docker container rm, and then I can put the container ID. But before that, let me just show you docker ps-e. If I execute, that is all containers it has listed, and here you can see two containers are available. Now suppose I want to delete this container. So what we can do, docker container rm, and then we can provide our container ID. Hit and enter. Now if I again execute docker PSA to list on all the container, here you will see it is now listing only one container because this particular container we have deleted. Okay, I hope it is pretty much clear to you. But again, I am keep on telling that once we are deleting container, stopping container, it does not mean our images are also getting deleted. Okay, images will be there. Like for example, if I am clearing this screen and then here I can do docker image, here you will able to docker images, here you will see that same images are available, right? Now suppose you want to delete this particular image also. So for that what you can do, just like docker container rm, we can delete a container. Similarly here docker image rm, using this command we can delete an image. Rm command anyway I hope you all know in the shell scripting is used to remove a file. Similarly to remove a container we can use that using docker container rm, and same kind of command we can use like docker image rm to remove an image. So I can execute that docker image rm and then here I can provide this particular image. Okay, welcome app, and I can hit an enter. Error response from daemon, unable to remove repository. This one container is using it. Okay, so what it is saying is like you cannot simply remove an image if some container is using that particular image, right? That is also very important safety check kind of thing they have implemented. So we need to execute docker container ls, or maybe I can execute docker container ps-a, and here you can see we are having one stopped container, right? So this container first we have to delete the base image or the welcome app image, whatever we have created. Okay, so for that I can delete this particular container, not a problem. So docker container rm and the container id we can provide. Okay, and we can execute. Now let's execute docker container psa. Here you can see currently no container is there. Now we have successfully deleted all the containers which are dependent on our docker image. Now we can run this particular docker image rm command to remove the image whatever we have created. Okay, and you can see it has deleted successfully. So now if we do docker image ls, here you will see only the base Python image is available to us, not the welcome app image whatever we have built using our docker file, right? So this way you can easily play with docker. I hope the fundamental concept of installing docker, running an application in EC2 machine within the container, how to do port mapping, how to list container, get the container ID, how to create container out of image, how to create image from a docker file, all these concepts are clear to you. So I'll provide these particular comments in the description box or in the comment section also. Try to practice this, because once we do hands-on in it, we'll have better idea out of it, and that is very important, right? So this is all for this section. We'll catch up in the third section. Thank you. So now we are in our third section of this particular video, and here we are going to explore how to deploy Python Lambda function with Docker container images. Okay. So for example, as we know that in Lambda execution environment, by default, certain Python packages or modules only available, not everything. But suppose you need to use some Python module which is not available in default execution environment, that time we generally opt for Lambda deployment safe or Lambda layer based approach. But apart from that, we can build a Docker container image where all the necessary required Python packages we can install beforehand along with our Lambda code, and then that image we can put in Elastic Container Registry, which is nothing but a service provided by AWS to store Docker images, right? And using that, we'll try to create our Lambda function. Okay. So here for this particular demo, I have taken a very simple Lambda function. We are importing request module, and then we are basically making a GET request to this particular endpoint. So let me first show you. Here if I just hit this particular endpoint in Chrome, here we are getting this kind of response. Now we will try to regenerate the same using Python programming. So I will copy this particular piece of code, and then here I will go to Lambda. And then here I'll go to create function. Here I can give the name demo test yt ECR. Okay, and the execution environment maybe I can choose, for example, Python 3.12, and then here I can create the function. So here I can paste that particular code and I can click on deploy. Now here let's test it out whether it is working or not. And here you can see the execution failed. The reason of failure is no module name request. So request module is not available by default in our Lambda execution environment. So either we should go with Lambda deployment zip or we need to create Lambda layer. So what we are going to do now in this section is we will create a Docker container image to resolve this particular issue. We will basically install all the dependencies in our Docker image, and using that image we will try to create our Lambda function. Okay. So these steps are mentioned in this documentation. So I will follow this particular documentation and create this particular process. Now, as a prerequisite, here it is clearly mentioned that to complete the steps in this section, you must have AWS command line, Docker and Python installed. Okay. So let us quickly do that using our EC2 machine. So in our EC2 machine, obviously by default, AWS command line will be there. Apart from that, we will install Docker and Python also will be available there. Okay. So here instance running, currently no instance are running. So I will launch one Docker cluster here. And then here Linux machine I'll choose free tier 1, I can opt for it. And then here let it be key pair name, I can choose this one. And then here if needed I can allow this graphics as of now. And then here in advanced details you can control the IAM roles if needed. For example, I can choose some IAM role where the EC2 machine will have S3 and ECR access also. Because in the subsequent steps, we might need to push that image from EC2 to ECR also. So for that, I will just quickly create one IAM role. Okay. So here I will go to IAM. And then here I'll go to roles. And then here I'll go to create role. And here service, I will choose EC2. And then here I will click on next. And then here I will search for S3 full access as of now I will be providing. Apart from that, ECR access also I need to provide. So this particular EC2 instance profile, ECR role I am choosing. And then I am clicking on next, the role name, EC2, ECR, demo, Y2. So this name I am keeping, and then here I am creating this particular role. Okay. So this role got created. Now I will go to this particular EC2, and here in IAM section, I will choose this particular role, and I will have that option. And keeping all other properties default, I can launch this particular instance. It is going to take few seconds to launch it, and initially it will be in pending state, and then it will go to running state. Once it reaches running state, we will follow the steps whatever we followed in our earlier discussion to install Docker image. That is, for example, these are the installation steps we need to follow. So we'll do that. So currently here you can see it is in pending state. Let's refresh it. So here you can see currently our cluster is in running state. So what I will do, I will copy this particular public IP and I will use putty to enter in it. I'll paste the host name, and in authentication I'll choose the PPK file and I'll open it. Click on this yes button and log in as EC2 user. And to avoid timeout, I'll change this particular setting to 10 seconds and I'll apply this one. Okay, that is done. Now as a first step, what we'll do, we'll update if anything is not updated. So sudo yum update y, this command will be executing, and then as part of the next step, we'll install Docker in it. So here Docker installation completed. Now here we can start the Docker service, and here it is started, and here I will give the access to EC2 user, and it is done. Now I can close this particular one. Okay, and then I will again use putty to enter in it so that proper accesses will be granted. So here I'll go to SSH authentication. I'll choose the PPK file again and I'll open it. Log in as EC2 user. Okay. To avoid timeout, I'll change the connection setting to 10 seconds. Now our Docker installation is done. Now let's follow the next steps. So here create an image from base image. So what it is mentioned here, create a directory for the project and then switch to that directory. So mkdir example. So example will be our directory and then cd example. Okay. So we are now in our example directory. Now we can create our lambda function with the name lambda function.py. Okay. So vi lambda function.py we can put. Let me just copy this particular name instead of typing, and I'll paste this and I'll hit an enter. So here now I can go to insert mode, and then here what I can do, I can paste this particular code what we ran earlier also. Okay, I have pasted it, and then here I will basically do write and quit. That is done. Now let's see the next step. So as part of the next step, it is saying that you can basically put all the external dependencies in requirements.txt file. So that also will be creating vi requirements.txt. And I'll hit an enter. I'll go to insert mode. We only need one particular module, and that is request module. That's it for this particular use case. You can mention as many required dependencies here as required, and I will do w2. So our requirements.txt file is also ready. Now as part of the next step, what it is mentioned that we need to create the Docker file, on which I discussed already in my previous videos in detail. The importance of from, copy, run, copy, command, all these things is explained. You can check the section 1 and 2 if you have not gone through that already. And then here I can create the Docker file. I'll hit an enter. I'll go to insert mode again, and then here what I'll do, I'll copy this particular code and I'll paste that here. So here as a first step, what we are doing, we are taking a base image, that is this one. We are copying the requirements.txt to this particular location, which is basically available in our Docker environment in that isolated execution platform. And then first we are running a pip installation command to install all the necessary external modules, whatever we have mentioned in requirements.txt. And then we are going to copy our lambda function.py from our current host machine to our Docker environment. And when our container will run, that time it should call this lambda function.handler, right? So that command we are executing here. Cool. Because here if you have seen that when we created the lambda function.py, the function name is handler. So within lambda function, the function name is handler. So that's why when we are running the container, the command we are putting lambda function.handler. Okay. In insert mode, I will just simply do write and quit. So with this, if I do ls, currently our Docker file lambda function.py, requirements.txt, all these files are available. Now what we can do, we can execute this particular command to build the Docker image out of it. But rather what I can do, first let me create the ECR image here. So here I will go to AWS Management Console, and then here I will search for ECR. And then here if you click on this left side, here you will be getting the repository option, where basically we can put all the images whatever we can create. So I'll create this repository. As of now I can put this private repository, because from issue 2 when we will try to access this ECR, that time using IAM role it can be easily accessible. But if you want, you can keep it public, but that will be less secure. So better to opt for private one, what generally industry follows. Okay. So demo yt ECR lambda, some name I have given, keeping all other properties default. I will simply create this particular repository. So here let's see what is happening. So here our repository got created. Just click on this particular button, and here it will show you the push comments whatever we need to execute. So first we need to basically copy this particular one to get the authentication token and all this information. So here I will do that. And here login succeeded. So login is successful. Using IAM role, it got authenticated. And then now as part of the next step, we need to build the Docker image, right? We have the Docker file. Now the next step is we need to build the Docker image. So this particular thing I will copy. If we are in our current working directory where our Docker file is available, that time this particular command will pick up that Docker file and it will create the image with this particular name. That is also fine. So I'll copy this particular one and I'll paste that here and I'll hit an enter. So here in the background now it started following all the steps whatever we have mentioned in our Docker file, like starting from installation, that request module download, copying the files from our host machine to our Docker system. All these things, step 1, step 2, step 3, it will do in the backend. You can ignore if any warning it is throwing. Now, as part of this step 3, what we need to do, we need to tag this one. So just simply execute this particular command. It is tagged, and as part of the next step, we need to push that particular image to our ECR repository. So here I will paste that one and I'll hit an enter. It is now pushing that particular image from our EC2 to ECR. So let's wait for a few seconds. So here it is done. So now what we can do, we can close this particular screen, we can refresh if needed. Here our repository is ready. Now using this particular image, we can create our Lambda function. So we can open AWS Management Console in a new tab. And then from here we can go to Lambda. And here I can click on create function. And here I can choose container image. The function name I can provide Lambda using ECR Docker. Okay. Right, and then container image URL I need to put. So I'll browse that image. I will choose my repository which is available, and this particular image I will select it. Okay, and no other properties needed to be changed. If you want, you can change the IAM role and all, but this is not needed as of now. I'll just simply click on create function. Okay, so let's wait for a few seconds until the function get created. So here our function is ready. It will not show you the code basically because here it is inside our Docker image. So here it is still creating phase. Once it get created, here it will show in green color. Then we can start running our Lambda function. Okay. So here it is done. Now what I can do, I can deploy as an API and then I can try to hit that one. That is also possible. Or we can directly test it out. So here is we are having our test option. Earlier we saw when directly we tried to execute due to unavailability of request module it failed, but this time if we test, let's see, and here it got succeeded, and here we got the response beautifully. If you observe, initially whenever we hit using Google Chrome, that time whatever response we got, that similar kind of response, now we have achieved that, right? So this way you can create Docker image and then create Lambda function out of it. All you have to do, whatever external module dependencies you want to install, you can do all those installation while building that image itself and then push in ECR, and from that ECR you can create your Lambda function, right? So I hope you understood this particular lab section. We will catch up in the lab 4 of our discussion. Thank you. So now we are in our third section of the discussion. So what we are going to do in this particular section is basically we will try to run our Docker container in AWS ECS. Elastic Container Service. Okay, so for that here I have created a very simple Flask app. We will try to run that first in EC2 instance by installing Docker in it, and once we test it out successfully there, we will try to map that same in ECS. Okay, so let me first quickly launch one EC2 machine. So here I'll go to instance and here click on launch instance, EC2 Docker test, and Amazon Linux image I will choose this one and let it be T2 micro free tier eligible. Key pair I will choose one existing key pair, and I will check as of now this HTTP and HTTPS traffic and I will launch the instance. So currently our instance is in pending state. I'll click on this particular security section and I will make sure that this particular security group allows all traffic from IPv4 location, and I'll save this rule. I'll go to EC2 dashboard, and now here let's see our instance state. Let me refresh. Still the instance is not in running state. Let's wait for a couple of minutes, and yep, here our instance is in running state. I will use putty to login in it. Click on yes, login as default login ID as we know EC2 user. Now what we'll do, we will quickly install Docker in it as we discussed in our previous sections also. So here nothing to update, and now we will install Docker. So here it is completed. and now I will start the Docker service. It is done. I will just give the permission and it is done. I'll close this particular terminal so that when we will launch a new terminal, the permissions will be updated. So I will again use putty to log in it. To avoid timeout, I will just change this particular setting to 10 seconds. Cool. Once that is done, we are going to create one directory and we will go to that particular directory. And here we need to create 3 files. One is Docker file, another one will be our Flask app, another one will be requirements.txt. So here in Docker file, what we are doing, first we are taking the base image Python 3.8, we are copying everything from our current host working directory to the app directory. In that Docker execution environment, we are defining the /app as our working directory. We are installing all the required modules and we are running this particular command when our container will be up and running. So here first let's go through our Flask app. Here what we are doing, we are first installing the required modules. We are creating our app, a very simple router. As part of our default page, we are keeping hello world, welcome to Bitcoin API. And here in the data extractor part, what we are doing, whenever this particular resource path will be provided in our main base URL, it will make a GET request to this particular HTTP endpoint, which is basically returning us the current Bitcoin price value, and that we are finally returning as message.txt. Okay, and we are running our this particular Flask application in port 5000, a very simple Flask app. Now I will quickly create this particular app.py. I'll go to insert mode and I'll paste this particular code :wq, write quit. Once that is done, we are going to create our requirements.txt file. I'll go to insert mode, and here basically I need 3 Python packages. One is Flask, one is request, one is URL lib3. Also we are doing a pip install just to avoid any unnecessary error. And then here our requirements.txt file is also got created. And now this is our Docker file. This part is self-explanatory as we already discussed in detail in our section 1 and section 2. So I will just quickly create this particular Docker file with vi Docker file. I'll go to insert mode and I'll paste this particular Docker file commands. Cool. So now if we do ls, here currently in our working directory app.py, Docker file and requirements.txt, these 3 are available. So now what we are going to do, we are going to simply build our Docker image. So this is the command what we discussed already, docker build -t welcome app dot. So this particular dot is going to help us in finding out the Docker file in the current working directory. Based on that, it is going to build the Docker image, which will be tagged this particular name welcome-app. And I will start building that image. It is going to take few seconds. Let's wait for that. Let's wait for that to complete. So again here we are getting some kind of warning. You can ignore these warnings as of now. And now here if we do docker image ls, we'll able to find out the images created recently. So here if I just paste this command and run it, so welcome app, basically that image what is built from our Docker file, and this Python 3.8, this image we have considered as base image for creating our custom image, right? So these 2 images are there. Now let's first run this particular container based on this image to test whether it is working properly or not. So for running any Docker image, we can use this command as we already discussed, docker run -p 5000:5000 welcome app. So this welcome app is basically this particular image it will refer, and this -p 5000:5000 is basically helping in port mapping. From the container port 5000 we are mapping that to host port 5000 so that we can easily access from EC2 public IP itself. And now here I will run this particular Docker container, and here our container is started. Now we should be able to access this particular Flask app from the public IP of EC2. So I have copied the public IP of EC2. I will just put 5000 port number and let's see. And here you can see our simple app, hello world, welcome to Bitcoin API is perfectly working. But let's also check the resource path get Bitcoin price, that also. So here what I will do, I'll give this particular resource path along with it, and when we will hit an enter, it should return the current Bitcoin price. And here you can see it is returning. Basically it is using this particular Coinbase API in the backend, and it is fetching that result set and it is returning. I am just showing with a very simple Flask application. You can understand this particular concept and use this particular concept for building any complex Flask application and hosting that in Amazon ECS service. Okay, so here if I just hit again this particular one, you can see the amount will be keep on changing because this Bitcoin price changes in real time. Like here currently 41131.55. If I just change it, now see the values got changed to 41129.275. If I make another get request after a few seconds, again the Bitcoin price will change. So here it is continuously keep on changing. So currently we are running our this particular Docker container from EC2, but AWS has one particular service which is ECS, which is nothing but Elastic Container Service. It is used for container orchestration purpose. So let's try to put our image and the container in that ECS and let AWS manage it. So that we are going to understand today in this video. Okay, so I will now stop my container because this is not needed. This just I ran for testing whether my Docker image is properly working or not. So here I came out of it. So now if I do docker container ls, here you will see currently no container is running. But if I do docker container ps-a, that time here you will see that earlier one container which was running, that it has displayed, and it is clearly showing it created 2 minutes ago, and currently the status is not running. The status is exited, right? Because we pressed Ctrl C to come out of that particular container run, right? So the container is stopped, and we have ran the container. We understood the image is perfectly working. Now what we will do, we will push this particular image in ECR. So for that pushing purpose, we need the proper role. So I will just check on this particular EC2 instance and I will change this IAM role. So I will go to action, I will go to the security section, modify IAM role, and here I will search the EC2 ECR role which we already created in our previous video, so that the EC2 service can easily interact with Elastic Container Registry, and I will update the IAM role. Okay. Now what we will do, we will open AWS Management Console in a new tab, and here we will search ECR. So as we discussed already, ECR is nothing but just like our Docker Hub. Like in GitHub we put our code, similarly in ECR we can put our Docker container images. So here I will click on get started, and here first we are going to create a repository. It is always better to put the repository private, right? So here I will give the name demo yt ECS Flask app, some name I have given for my repository, and I will click on create repository. So here our repository is created, right? Click on this and click on view push commands. Here you will be getting all the push commands, whatever you need to execute from your host machine to push that particular image to ECR. Okay, so here let's see our image. So here I will clear this, and here I will execute docker image ls. Okay, here you can see our image is there. We need to push this particular image, right? And that image we have built in our current working directory. So we can just execute all these commands one by one, and the image will be automatically pushed. So first we will log in. It will authenticate based on role, and here docker build -t demo test flask app dot. So it is going to build that particular image with this particular tagging. Anyway, we are having one particular image already built, but let's execute this. It will just create the new image with this particular tagging. So that is also done. Now if I do docker image ls, here you will see one more new image got created. That is also fine, no problem. and here I will tag this command. That is done. And as part of the last step, we are going to push this particular image from our EC2 host machine to our ECR. Okay, so here you can see it is pushing that particular Docker image to our Elastic Container Registry. Okay, so let's wait for a few seconds. Let the push get completed. Till then, what we will do, I will just give you little brief introduction about the ECS service. Okay, so in simple words we can say here ECS, it is nothing but container orchestration service provided by AWS. Okay, so it is like this way. Here we are having ECS cluster, and here we will be having something called task definition. And what this task definition will do, basically we are going to provide the image name. Okay, so we have pushed this particular image in ECR, right? From ECR, the image we will be putting in task definition. Okay, and based on this particular task definition, within our ECS cluster, containers will be launched. Okay, and remember this thing that in ECS the containers are termed as task. Okay, so this way our task will be executed. So what we are going to do, first we are going to create one ECS cluster and we are going to define one task. Okay, that is called task definition, and we will basically launch our container. It is nothing but called as launching task or service within our ECS cluster, and that will be launched based on the image whatever we have pushed in our ECR. Okay, so this is the rough architecture how our ECS and related ecosystem works. Okay, so now let's go back to our EC2 console. So here you can see as of now our Docker image is pushed in our ECR repository. So here I can go to this particular repository and here you can see our image is available. Cool. So now what we will do, we will open AWS Management Console in another new tab, and as part of the first step in our ECS, we are going to launch one ECS cluster. Okay, so here I will search for ECS, and here you can see Elastic Container Service is available. So currently we are having no cluster in our AWS account. I will just simply click on create cluster, demo YT flask test app, some name randomly I am giving. Now this ECS cluster you can launch in two ways. One is either you can use AWS Fargate, which is serverless service. Another one is by using AWS EC2 instance. It is better to use AWS Fargate in this case because the app is very simple, and let AWS take care of all the infrastructure management, scaling up and all these things. So we can opt for serverless and we can create the cluster. It is going to take few seconds. So here you can see the cluster creation status is in progress. So let the ECS cluster get created. By that time I will create my task definition based on the image whatever we have pushed in our ECR repository. Okay, so here we have open task definition, create new task definition. I'll click on that, and here task, so flask app image task, some random name I have given. Launch type AWS Fargate, yes, that is correct. Operating system, so the image we have built on Linux machine, so let it be Linux, not a problem. The task size, CPU, memory, how much it is needed based on your app and its complexity, you can define that. This default configuration is fine for this simple app. Task role, so suppose your task need to interact with different AWS services, that time you can provide specific role, but for our this particular Flask app or this task, we no need any other AWS service interaction, so we are going to keep this particular section as blank. Okay, and now here we are having task execution role, let it be default. Right, now here container name, so as I told you, right, that in task definition we are going to provide the image from ECR, so that we are going to implement in this stage. Container detail, so here name I can give Bitcoin app, and the image URL we need to provide. So here we are having our ECR. I will just click on this particular image, and here we are going to get the URL of that image. I'll just simply paste that. Okay. Now here port mapping we have to do. So what is port mapping? Already I have discussed in detail in our section 1 and 2. Basically when we are running the app from EC2 machine, then our Flask app is running in port 5000, but that is within container. We cannot access that particular port from the host machine. To do that, that means to access the 5000 port from container, we need to do the port mapping, where the container port 5000 we are mapping to host port 5000. So here we need to mention that same thing. So container port 5000 we are going to expose or map to the host port. Okay, CPU, GPU, these things I can keep as default, not a problem. And then keeping all other properties default, I will simply create our task definition. So here our task definition is created. Let's go back to our cluster, and here you can see our cluster is also created. Now click on this particular cluster. Here you will be getting two options, service or task. Service is something which ideally should run for a very long time, maybe 24/7, 365 days it should run, or maybe you can think like this way, if something goes down automatically it should restart. That kind of, like for example website, if you want to launch, that time you can opt for service. So here in this case we are basically creating a Flask API, which is nothing but kind of we are expecting to run for a long time, so we are opting for service instead of task. Click on create. Existing cluster, let it be, and then here capacity provider we can keep Fargate, not a problem. Now service I can choose, it is not a task. Task is nothing but kind of a bad job we can implement here, but here in this case it is nothing but a web app or API kind of thing, so we are opting for service functionality. And then family we need to choose. So here family means task definition. So when we are saying service, that means we are going to launch our container within ECS cluster. Now the container will be launched based on the image whatever we have provided in the task definition, right? So we are going to choose that particular task definition, whatever we just created now. Now the service name we need to choose. Service, what name we can give? Flask first service demo YT. Some random name I have given. Service type replica, let that it be fine. And then desired task I am keeping 1. So that means this service should run at least based on one task. If suppose that task is also down for some reason, then the AWS ECS service should automatically try to restart the whole process, so that our API will be running 24/7. Okay. So desired task, let it be at least 1. And then here in networking, so here as of now I am opting for default VPC, which is having internet access. So you need to make sure your VPC and the security group where you are launching your task, that is having internet access. Like I can show you here, this is the security group I am using. Now if I open AWS Management Console in a new tab, and here if I search VPC, and here if I go to subnets, and if I search for this one, sorry, this is security group, right? So here I will go to security groups, and then here I will search for it. This is the default security group. I'll click on edit inbound rule, and here you can see as of now it is allowing all traffic. Okay, so all traffic from anywhere it is allowed, so it will not make big problem with respect to accessing our API endpoint from web. Okay, and these subnets, or we can say this VPC, is having route table where we are having internet routing mechanism implemented, so we should be able to access the API without any issue. And without any other changes, we will simply click on create service. Okay, so here it is again going to take few seconds to start the service, so I will just refresh this screen. So here you can see that our service is launched. Currently we are expecting at least one task should be started. That means one container at least it should start. Currently here 0 task is running. Even you can click on this particular service and go to task section. Here you can see it is in pending state. Soon it will be in running state. Once it is in running state, we will try to access that particular API using the public IP of this task. Okay, so here I will refresh the screen. So here you can see currently our task is in running state. Okay, click on this particular task and here you will be getting the public IP. I'll copy the public IP and then I will go to Google Chrome. I'll paste the public IP and our Flask app is running in port 5000. So I will give :5000 and I will hit an enter. And here you can see beautifully it is going to the landing page. Hello world, welcome to Bitcoin API. And now let's see whether our resource path is also working properly or not, that is get Bitcoin price. So here what I will do, I will paste that as resource path and I will hit an enter. And here you can see it is fetching the current Bitcoin price in USD and it is showing here. Okay, it is not at all coming from our EC2 machine. So we just launched our EC2 machine because we don't have Docker installed in our local system, right? Since beginning I am discussing Docker in cloud. So again, if you are having Docker installed in your local system, you can create the whole image in local and then push in ECR. You no need to launch EC2 machine. Okay, even I can show you to avoid confusion. Now what I will do, I can terminate this particular EC2 machine, not a problem. So for that, first I will close this particular putty console and I will click on terminate. Okay, so that way our EC2 cluster will be terminated. So here you can see it is in shutting down stage. Okay, cool. So the API which is hosted in EC2, that is not at all running now, it is shutting down. But here this particular API is hosted in ECS, right? So it is accessible. If I go to our default page, that is landing page, here it is throwing hello world, welcome to Bitcoin API. And here if I go to our resource path, here it is showing the Bitcoin amount properly, right? We no need to bother about EC2 at all, right? So this way, in a serverless manner, you can orchestrate your container services and run in AWS ECS. Okay, another beautiful thing I want to show you about ECS, and that is, suppose due to some reason, here let's see, here we are having our cluster and here we are having one particular task running for only one service in our ECS cluster, right? Now for suppose some reason the task is stopped, maybe some failure occurred or due to some network issue, for something the task is stopped. You know what this ECS will try to do? It will try to launch that particular task again for that service, because while launching this service we have clearly configured that at least one task should be running always. So let's see that whether it is working or not. So what I will do, I'll click on this particular task and I will click on stop selected, and I'll click on stop, and here you can see stopping the task. So intentionally here I am stopping the task just to show you that ECS will automatically launch one particular task if it is not matching with the desired task count. So currently we are having 0 task running, but the desired is 1. So if I refresh the screen, here you will see that 0 out of 1 task running. And here API, if we are trying to basically, if I maybe it is happening due to some cache, if I just try to access, here it is still running. So here let's see what happened. So here service, I'll go in the task section. So here it is in pending state. Let me just close this one. So here you can see it is rotating. That means it is not able to find out our port or endpoint, whatever we have created, because we intentionally stopped that particular task, right? But here ECS, you can see in the backend again launched another task and it is currently in pending state, and eventually it will start running it. Okay, so here you can see currently that particular earlier URL is not reachable. Even if I just put get Bitcoin price, here you will be able to see that that particular URL will not be working because we intentionally stopped the task. But because we have configured that desired task is 1, here you can see automatically here again it launched or auto healed itself and launched a task. And here if I go to task section, here I will be getting a new public IP and that we can access. So here earlier IP was this. Let's see what is the current IP. 54.234.243.23. Earlier one was different. So
every time when task is launched newly, the public IP will be changed. You can obviously maintain that using load balancer and different services. So this particular older IP is no longer useful for us. We can use this particular new public IP, and along with that I can put the port number, and we should be able to access our landing page. Hello world, welcome to Bitcoin API. And here if I try to access this particular resource path, get Bitcoin price, here you can see perfectly it is working. That means using this particular lab section, I just tried to show you that ECS has that auto heal mechanism as well. Okay, right? So I hope in this particular section the concept of ECS, task definition, task, AWS Fargate is clear to you, right? So if you have any doubt, you can just ask that in the comment section along with the timestamp where you faced the doubt, right? I will try to reply back ASAP. And in the service section, now I can stop this particular service because it is no longer needed. So I will click on delete service. I will opt for force delete and I will click on delete. Okay, so this will make sure our complete stack, that is ECS cluster, services, task, all things will be deleted, so that we will not get unnecessary cost. This is just we are doing for POC. You might get some cost for doing this POC, but that will be very less if you are using this wisely. Okay, just make sure to terminate all the services or AWS process whatever you have launched, right? So here let's go back to our cluster and let's see. So here currently no service is running and I can delete this particular cluster now. And here you can see the cluster is getting deleted. Let's wait for a few seconds. And it is done. I'll go back to cluster. Here you can see no cluster is there. What else we launched? We launched task definition, right? So click on that and maybe here, and then I'll click on this action deregistered. I'll click on deregistered. Once it is deregistered, I'll go here and then again click, I'll go back, click on this. Here we should be getting the option to get the inactive task definitions, and I'll click on action and I'll click on delete. And it is deleted. Okay, now we can delete this task definition as well. So here I will refresh the screen, and here you can see the task definition is deleted, right? So this way we have deleted the clusters whatever we have launched and the task definition as well. Apart from that, the EC2 machine whatever we have launched, that also we have deleted earlier. Let me just show you. I'll go to EC2, and here you can see instance running is 0. Apart from that, this repository whatever we have created, that also I can delete. I'll click on repository. No public repository is there, we are having private repo. I'll click on this and I'll click on delete. So with this we are done with the cleanup activity as well. So I hope you enjoyed this particular section of our Docker playlist. This is all for this video. We will catch up in the next section. Thank you.
So in our previous section, we have basically explored how to run web service in AWS ECS, where ECS backend is supported by AWS Fargate, right? Now it is not like always we will be working with some web service. Sometimes we might need to run some sort of batch ETL workload, which will be maybe pulling some data from some location, process it, and then load in some destination system, maybe that is Snowflake, S3 or DynamoDB, etc. And then we can terminate that particular process. That means I am trying to say that not all containers whatever we will be launching in AWS ECS are long running containers. Sometimes we might need to launch some task or container for a very short duration. It will do that batch computation and then it will be getting terminated. So how to implement that using AWS ECS, on that we are going to explore in this particular section of the discussion. Okay, so let's go through the code first. It is a very simple code. All I am doing here, if you see, first I am importing all the necessary modules, and then here for our experimentation purpose we are choosing the region as US East 1, And here I am basically taking current time in IST, that is Indian Standard Time. I am having a particular DynamoDB table, and the table name is Bitcoin Price Storer. What we are doing first here, we are creating the both-of-the client for our that particular DynamoDB table, and then here we are putting some item in it using this particular function. Okay, I hope up to this it is very simple. And in the main function, what we are doing, using this particular Coinbase API, we are extracting the current Bitcoin price in USD. We are taking that JSON data in this data variable, and then here data to ingest in DynamoDB, that we are configuring here. Like for example, amount column is there, base column is there, currency, and then timestamp. Timestamp, I am basically taking my current ITC timestamp, and then along with that, as you know, in DynamoDB table we should be putting some primary key. So for that I am taking UUID. Okay, that string of UUID.UUID4 I am taking, which will be always returning some sort of unique value, which we can put as primary key in our DynamoDB table. Okay, and then we are calling this particular function to ingest this particular Bitcoin price information in our DynamoDB table, and then we are printing that the data is successfully ingested, and then we are printing data transfer comp, and then we are calling our main function. So this is basically kind of a batch ETL workload you can think of. What suppose we want to run in Fargate using AWS ECS. Okay, so what are the requirements.txt? One is the request module we need for making a GET request to our Coinbase API. Then URL lib3 we are also installing, which is kind of interrelated with request module. Boto3 is needed to ingest the data in DynamoDB table. We need to create Boto3 client, so that we are creating. And then to get the IST time, we need PyTZ, and UUID we are using to create the unique ID or primary key for our DynamoDB table. Okay, and the Docker file also we are creating a very simple Docker file from Python 3.8. We are copying everything from our working directory to the app folder. Within our Docker execution environment, we are configuring app as working directory. We are installing all the packages, whatever mentioned in requirements.txt, that is in this particular file, whatever we have mentioned that we are installing. And then we are running Python app.py. Okay, app.py is nothing but, here, right? And then we are running here Python app.py, which is nothing but our this particular Python batch ETL code. Okay, right? So this particular code we are going to run using AWS ECS, right? So for that, first I will launch EC2 machine. There I will install Docker, and I will create the image, and then I'll push that image in ECR. All these steps I'll be doing what I already did in our previous video also. So here I will search for EC2, and then here instance running I'll go, and currently no instance is running. I'll just launch instance Docker cluster demo YT, and then here Amazon image I'll be choosing this one, and T2 micro, this is fine. Key pair I'll be choosing one existing key pair. I'll allow both of these as of now, and then here IAM role also I need to choose. So here already I have created EC2 ECR role. I need to make sure that this EC2 is having ECR role as well, because when we will create that particular image, now to access from ECS we need ECR, right? So here EC2 ECR demo YT, and along with that I will just make sure one more changes. So here in a new tab I will look for IAM, and then here I'll go to roles, and then here I'll search for that particular role. This is the one, and here I'll make sure the DynamoDB permission is also attached, because our code is basically going to write the current Bitcoin price in DynamoDB table. So the execution environment should have DynamoDB access. Okay, so here DynamoDB full access as of now I am attached. Cool. So that is also done, and then here without any further delay we can launch our EC2 machine. So here this is our instance, and currently it is in pending state. I will just change the security also. I'll just make sure as of now from anywhere IPv4 location this particular code is accessible, and I'll save this rule. So here it is saved. I'll go to EC2 dashboard, instance running. I'll copy the public IP, and I'll open putty to log in it. click on yes, login as EC2 user, and I'll make sure I'm not having timeout issue. So connection I will change to 10, and I'll click on app. Okay, up to this it is done. Now here what I will do, we will first update if anything is not updated, and then here I will install Docker, and then as part of the next step we can start the Docker, and then here I'll update the permission also. That is done. I can close this terminal as of now, and then again re-enter in it using putty. Click on open and login as EC2 user, and then as part of the next step, first I am going to create a directory and I'll enter in that directory, and then here I will go to this Docker file and create that. So CI, and then here Docker file, I will go to insert mode, and then here I will paste this particular code. And then here I will create my app.py also. I will copy this particular code and paste here, and that is also done. And as part of the next step, I will create my requirements.txt file. And then here I'll do ls. As of now, in our current working directory, app.py, Docker file, and requirements.txt should be available. Okay. Now here what we are going to do is basically we will create our Docker image out of it. So let the Docker image get created. By that time, here what I will do, I'll create my DynamoDB table also, because when our code will run, it should already have this particular DynamoDB table created, otherwise it will throw some error that it is not able to find out the DynamoDB table and so on. So I'll go to tables, and then here create table, I'll paste this particular one. Now partition, so in our case the primary key is EUID, so I will choose that, and in partition key I'll paste that. Let it be string, not a problem. Keeping all other properties default, I'll simply create this particular table. Cool. So the table is in creating state. Let's wait for a few seconds, and you can see the table is created. Right. Now here what we'll do. So here Docker image building process is going on. Once it is done, we will execute Docker image ls to view whether it is created or not. And it is done. Now if I do Docker image ls, here you can see our welcome app is created. Right. Now here we can run our image to create the container where our code will run. Okay. One thing to note here is, here I have not done port mapping, because this does not need any kind of web access or something like that. So we can simply run our container. Okay, Docker run welcome app. Let's try it out. And here you can see data transfer complete. This particular item, which it basically fetched using Coinbase API, that is added to the DynamoDB table Bitcoin price total. So let's see. Just now we created this particular table, right? So here I will click on explore table items, and here you can see beautifully we are getting the data. EUID this, amount current Bitcoin price in USD is this one. Time, if you observe, currently it is 7:14 PM in IST, and you observe the timestamp, it is also showing 19:13:37, that is 7:13 PM, right? So that means just now the data got inserted properly. I can run this particular code again just to show you that one more entry will be inserted with higher timestamp value. If I refresh here, you can see two entries are there. One is at 9:13, our older entry, and new entry is at 9:14 PM. Okay, that means our this particular Docker image is perfectly built, and it is doing that activity what it's supposed to do. Okay, now we need to run this particular code from Fargate using AWS ECS. So here what I will search for, I'll search for ECR to publish our this built image to our ECR repository. So here I'll go to ECR, and then here maybe I can delete one existing if it is available, just to avoid any confusion. Otherwise you can keep it. Create repository. So here I'm keeping this private, and here Docker ETL demo Fargate. Some name I have given, and then here I'll click on create repository. So here our repository got created. Click on this particular bullet, and here you will get the push comments whatever is needed. Okay, so I will execute all these push comments one by one. I'll create the image with this name, whatever our ECR has suggested. It is done. I'll tag it, and then as part of the last step, I'll push this particular image to our ECR. Okay, so let it get pushed, and till then what I will do, I'll clear all the items, whatever is available in DynamoDB, so that we can run freshly from our AWS Fargate. So now if I go to our DynamoDB table and click on explore table items, here you will see that no data is available currently. Cool. So here let it get pushed. Till then what we'll do, we'll open AWS ECS where our actual project is getting started. So here I will look for ECS, and here we are having Elastic Container Service. Currently we are having no cluster. I'll create the cluster. Cluster name I can give demo batch ETL YT. Okay. Let the infrastructure be serverless, that is using AWS Fargate, and create this particular cluster. It is going to take few seconds. Till then I will create the task definition, okay, which is basically going to fetch the data from our ECR repository and going to launch the containers in our Fargate instance. Okay, so here I will click on create new task, new task definition, and here I can give the name YT demo test batch ETL workload. Some name I have given. Let it be AWS Fargate operating system. I don't want to change. Task role, I will choose a task role. Okay, just wait for a few seconds. I'll quickly edit that. Container. So here container name I can give batch ETL job test, and image URL. So let's see whether our image is pushed or not. Yep, it is pushed in our ECR. So here if I close this ECR window, if I go inside that, here you will see we are having one image. I'll click on that, and here the URL path I'll be choosing. Okay, so by the time here our ECS cluster is also ready, I'll just paste this particular image URL, and port mapping we no need to do, that is fine. So all other properties we can keep as it is. Only thing we need to change is this particular property, that is task role. Okay, so I will open IAM console, and I need to make sure the task role is having all the existing permission. Along with that, it should have access to DynamoDB, so that when our task will launch the container, it should be able to easily interact with DynamoDB to ingest the data in it. Okay, so here I will go to create role, and here I will search for ECS, or here Elastic Container Service, something like that I can choose. And this particular service task role I need to create, so I'll click on next, and then here I can search for task. Here you can see execution role policy, this one obviously we need. Apart from that, here we need DynamoDB also. Okay, as of now I am putting Amazon DynamoDB full access, that will work. And here role name I can give YT task ECS demo. Okay, and then here I can click on create role. The role is getting created, and that particular role here I need to choose. Okay, so here this particular one, YT task ECS demo, that one I have chosen. So with this we can hope that when our task will launch the container should be able to easily interact with our DynamoDB to ingest the data in it. Right, now here what we'll do, we'll create our task. So let the task get created, and it is done. Now we can just try it out once. I'll go to our cluster. Earlier we have opted for service. Basically we needed to run the job for a longer time, that API whatever we have created using Flask. But this time this is just a batch job. So instead of service we will choose task. Okay, and click on run new task, right? And then here I can keep this particular one Fargate only, and task, the family I can choose. So here our task whatever we have created is this particular one, YT demo test. If you see this particular one workload, so that same we have chosen. Desired task one, fine. And then networking, the default one I am keeping, right? And I think all other properties we can keep default. Let's check our DynamoDB table once. If I refresh here, you can currently see there is not a single entry in it. And now what we can do, we can start our task in ECS cluster. It is going to run in AWS Fargate, right? So here you can see it is in provisioning state. Soon it will be in running state, and then it will be going to stop state. And then once the job is completed, we should be able to see one entry in our DynamoDB table. So currently it is in pending. Let's refresh once. So here you can see currently it is in running state. So here in our DynamoDB, see how beautifully one entry came. And this code is not running from our EC2. This code is running from our Fargate, which is supported by AWS ECS, right? And the job is a very temporary small job. So what it will do, once the run is over, it will go to stop state. So here you can see currently no task is available because we have selected running. So if I just choose any desired state, here you can see one task in our this freshly launched cluster is in stop state. That is basically just now whatever it ran, right? So this is how we can easily run batch ETL workloads in Fargate supported by AWS ECS. So I hope you understood this particular concept. This is all for this video. If you find this particular playlist interesting, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.